Hi, student. This is a unit number 2 of the video SolidWorks tutorial video series. And this video series is a collaboration between the Metro System Corporation and Department of Mechanical and Aerospace Engineering. In this video, we're going to discuss about how we can use some basic tools of SolidWorks to create a 3D model. Let's get started. This is the topic of this video. We're gonna discuss about the sketching and in details. In previous video, I give you some rough idea about how to create a 3D model. And if you remember correctly, there are three um, steps. The first step is going to be the plane selection. We just select a plane, and after that, you try to make a sketch, and you also need to add a sketch relations, right? And the way you can add a sketch relation is that you can add a relation manually, or you can use the default SolidWorks features to add the relation automatically. Like when you draw a horizontal line, SolidWorks gonna add the horizontal properties to such line. If you don't remember about this topic, you can go back to watch the Unit 1 video. After we finish the sketching in detail, we're gonna move on to the part modeling. We're gonna discuss about some basic SolidWorks tool that we're gonna use to create a 3D model. And we're gonna discuss about the pictorial views. This topic is going to be a part of the engineering drawing that you are studying in the main course of engineering drawing. Okay, and let's start with the sketching. Okay, first of all, you need to note about some sketch relations. As you can see in this slide, we have very common features of the sketch relation. The first one we call horizontal. If you draw a line, you add horizontal to the relation of that line. That means the line will be constrained to the horizontal plane. Okay. Similarly to the vertical, if you add the vertical relation to a line, that line will be parallel to the vertical axis of the coordinates. You also have a coincident midpoint perpendicularity. And it really depends on how you use them. The coincidence means that you need to select 2 points, and you can add the relation of 2 points to be exactly the same at the same position. And if you select midpoint, you need to think about a line. A single line always have a midpoint. If you add the midpoint to some specific point, for example, an end of the other line, the end of the other line gonna stick to the midpoint of the line that you choose to add the relation. We can discuss about this later. Okay, and you also have parallel tangent. It's very useful to draw a line to have a contact with a circle. You also have equal. You can make two lines to have the equal length by adding this relation. You also have collinear. If you have two lines and you want to have two lines arranged in the same axis, you can add collinear. Concentric is used for align two circles to have the same center. Corradial, fixed, and intersection, symmetric, and have some useful. We're gonna do this by example. Okay, first of all, I would like to let you know how to be basically draw this profile. This is a kind of just an example. There is no specific uh, useful for this profile. Okay, let's start with the SolidWorks, and you can start with a new part. When you click new part, you can have this kind of screen. So first of all, you need to select plane, right? In this case, I want to draw on a front plane. And after that, I click sketch and again, sketch. Okay. You can start to draw this profile by have this line with the horizontal relationship, right? You can just draw a horizontal line, and you have another line go into the northeast direction. You also can have another line. And as you can see over here, there is a perpendicular relation between this line, this line. That means this angle always equal 90 degrees. This one as well. If you add relation between this line, right, you can have a 90 degree added to the sketch. And after that, you have another line with the horizontal relation, and also another line with the vertical relation. Okay? So let's do this together. I'm gonna use line like this and move the line to the right. As you can see here, when you align this line with the x-axis, is the horizontal direction of these coordinates. A horizontal relation will be added automatically. So I'm gonna take this advantage by just draw a line. At first, we don't care much about the dimension, I mean the size of the line, the length of the line. We just simply draw the profile of our sketch. You can see here, the perpendicularity relation is added automatically. If you click, then I move along this direction, the perpendicular. And then I go back here with the horizontal, and I also have another one. And when your graphic screen show the area like this, that means you have a completely closed profile. Okay, you can press escape once to escape from the sketch. Anyway, you're still working on this sketch one. Okay, and after that, we're gonna start to add the dimension. You can guess that we need to use the smart dimension for this job. Okay, let's click on the line and give another click to place the dimension. And in this case, I'm gonna key in 32 as the length of this line, 32. Okay, as you can see, at first it's about 60 something, right? And when you give the first smart dimension, all of the dimensions adjusted in the same proportion that you start drawing this profile. It's very convenient. Okay, and after that, I'm gonna add the 125 degree and 150 millimeter for the distance between the origin to this point. Give one click here and another click at the declined line. I can move to this side of the line. As you can see, if I place this smart dimension over here, I need to specify the angle, right, of the open angle. Refer to the x-axis, but in this example, I'm gonna add the size, the angle from the other side of the line. So I'm gonna place this angle over here and I'm gonna put 155 for this angle. And I also have another length, which is from this one to this one. You need to carefully align the dimension. Like, for example, if you put the dimension like this, that means it's going to be the length between the origin, the displacement from the origin to this point. But if you try to align vertically, that means you're going to give the distance from the x-axis to this point. And in this case, I'm going to give the distance from the y-axis to this point. Right, that's the dimension right here. I'm going to key in 50 millimeter. Yes. So you might notice that some lines turn black already. That means all the black line refer to the constrained object or constrained entity. You cannot move them anymore. The movable part of this sketch is just only the blue one. For example, if there's the escape button to exit from the smart dimension, and try to move here. See, still movable because it's still in the blue color. Okay. So in order to have the complete sketch, you need to add more constraint or more smart dimension to constrain the sketch. So in this case, I need to add 20 over here and 25 over here. Let's see how it works. Give another smart dimension over here, which is the 20. We have three ways to place the smart dimension along the horizon axis, along the object, and also along the vertical axis. In this case, I need to add the dimension to control the width or the length of this line. So it's going to be 200. Okay. Last one, which is this dimension. This is a 25. Right. Seeing that all of the line turn back, and when I click to accept the sketch, as you can see here, there is no plus or minus sign at the front of this name. That means this sketch is complete, is fully constrained. For the sketch are in black color. Okay, I think you might need to practice about how to add dimension to complete the profile, and we're gonna discuss about the profile later, and we're gonna see that the plane that you select in the first place is very important, and the profile that you draw is also important to create a 3D model. Okay, and let's move to the next one. This is another example. I will give you to practice this on your own. It's very simple, right? As you can see here, you can start with select a single plane, one plane that you like, and you start to draw from the origin to the right with the horizontal relationship, right? And you go to the north, okay, along the vertical line. The vertical relation will be added automatically. After that, you go to here. In the first place, please remember you don't need to worry about the dimension too much. You just make the draft of your desired profile. And once you finish with the draft design profile, you just add the dimension later. And just keep in mind that you should keep all of the lines to be in black color to uh, to make sure that your sketch is unique or is fully constrained. Okay, and the profile is very important, as I mentioned earlier, and you need to know about this technical word, which is the best profile. Best profile is the sketch that you use to as a majority uh, to build a three-dimensional part. For example, this part, which is kind of a disk with something like an inclined plane with the hole. So in order to create this part, you need to think about the best profile. The best profile is the profile that you, when you create, your part is mostly complete. You know, in this case, if you create this profile, a circle with two knots, this, and you give the thickness to it, essentially, as you can see, is more or less, or it is mostly complete, right? At least you finish, let's say, 50% of your work already. Yeah. This one as well. If you think about creating of the side part of this part, okay? You just draw something like this, horizontal, inclined line. You give a thickness. This you have another inclined line. You have another horizontal line. And when you extrude it into this direction, your part is mostly finished. Okay? This is your sketch. You can see here. Another one is also this one. You might don't, if you are a beginner, you maybe not able to recognize the best profile. I think you have a look at the profile on the right. You might get some right? You might create a ball-like profile like this. And when you extrude into the vertical direction, the part is more or less the same already. So all the rest is just create a holes over here and over here. You cut some bit of this part, you create another two holes. You can create the cuts over here. You finally get the final. Okay, this one as well. I think you can guess that the best profile would be this one. This kind of a loaf of bread, right? And when you draw this profile, you just extrude to this direction. You are mostly finished. The rest is just create another hole over here and another two holes over here. And job done. Okay. This is how the best profile important to create a draw a 3D model. If you cannot identify the best profile, you need to work a lot to finish the job. We're gonna work on this part together. Let's start. Okay, first of all, we need to create this one. You might need to take some time to think about which sketch would be the main part of this 3D object. What you need to think about how the best profile look like. Okay, in this case, if you start with this bit and you just extrude to this direction, as you can see, it's just the, let's say, 30% out of the whole part, right? That's this part. But if you create a square like this, okay, and you extrude it into the vertical direction, yeah, That means that it's like 60 or 70% of this part is finished. So let's say in this case, the best profile would be a square. Okay? So first of all, I'm gonna create this square, and the dimension would be 125 and 40 millimeter, and the thickness of this part is 10 millimeter. So I'm gonna create another drawing. Click new, go to part, give a code, okay. We can start with this. The question is, which plane is the best that we need to choose? In this case, you need to go back to what you have learned in the engineering drawing class, right? The best way to select this plane is the plane that make your 3D model look most natural, right? So in this case, your part sits on the floor, right? And if you compare to the plane in SolidWorks, the floor would be exact plane. So in this case, I'm gonna start the sketch on the top plane. Okay. So first of all, I need to write a rectangle with a dimension of 40 by 125. I select top plane already. And then I go to sketch and start to draw a square, a rectangle. So as you can see here, we have many options. And it's 5 options to create a rectangle. So I can use corner to corner, right? However, in this case, I love to use the center and corner because they usually want to have the origin of the equipment to be placed at the origin of the parts. You can also use the 2 corners, right? By starting by clicking at the origin at the first corner, you move to the other. That is fine, but it really depends on the way you work. But I would recommend to put the center of the part at the origin. Okay, so I finished my rectangle already. And next step is adding the smart dimension. So I start adding horizontal line first. So this one is going to be 125, right? And I add this photo. And after that, you can go straight to the figures. And after that, you add the extruded boss base. Click this icon. So we're gonna turn the view into the pictorial view. This is we're gonna discuss about this very soon. So I add the thickness of this part by keying 10 millimeter. Actually, 10 millimeter is the default number. So if click to say yes, this is finished. And there are some shortcuts button on the keyboard. In this case, I'm gonna press F on the keyboard to zoom the 3D parts to fit the graphical area. I would suggest you to press the space bar, or you can go to this icon, view orientation. If you click the down list on the right, the arrow, the down arrow on the right, you can come up with this kind of an option. You have this one again, with the down list, and I would just ask you to try to use it. There are 3 types of the pictorial view. The first one, which is the one that we use most and we love it, is called isometric. ISO is similar, and metric means measure. Okay? So if you click to isometric, the angle of all between these two axes will be equal. So in this case, the angle between x and y will be 60 degrees by sine and sine x also 60 degrees, right? When this part is placed in the isometric view. You can try with something more. For example, you can have dimetric and trimetric. It really depends on the convention or the view that you want to show. Okay, but in mechanical engineering drawing, we usually use so you just do this option. Yes, and we finish this step already, right? We're gonna move on to the next. And the next step, we're gonna start to create the the surface semicircle. So we're gonna start to by selecting a plane. In this case, you can select directly this is the outline of a rectangular bar. We start to make a sketch over here. Select line. Okay. As you can see at this step, it's not very convenient to draw in the isometric view. To suggest you to place a space bar. After that, you can use normal tool. You can use shortcut by press the hold control button and number 8. When you use the normal tool, the sketch plane gonna be oriented to be perpendicular to the graphical screen. It's very more convenient to work in this view. So I'm gonna start with this line. This line is the horizontal line. This. If you give another click over here, that means you just disconnect the line. Start to work on the line. Double click. And you can add a circle. Again, if you want to add a circle, there are many way to there are some different way to in this case, if you want to draw a circle, you can specify the center of the circle and the radius of the circle. Or you can use 3 points to create a circle. But in our case, right here, what we need is an arc. Let's say this is a 3-point arc. Or you can also use circle as well. I'm gonna try to use perimeter circle. This is it. And we're gonna add the dimension. So this look like this is a complete semicircle, right? That means the center of the circle is aligned with the two ends of the semicircle. So what I'm gonna do is select center of the circle and this end of the line. Next, I want to add the relation by click on the horizontal. As you can see, the center of the circle and this end just going to the same line. I also need to add another relation by click the end of the line on the right and make again horizontal with the center of the circle. Yes. Okay, beautiful. And after that, I'm gonna add this dimension, 35, and the center of the circle is just 50 millimeter away from the this end. To the smart dimension. Yes, this. This one is 35, right? And 50. The radius of this semicircle is 20. Anyway, it's still a full circle, right? So what we can do is to use this tool, trim entity, to remove this bit of the it will suggest you to use trim to close it. You're gonna come up with a small scissor. Just move to here, click. The bottom part of the circle is removed already. And after that, the dimension to this semicircle 20 here. Next, the distance between this end to the center of the circle is going to be 50. All lines are black. That means this sketch is complete. Give a click to exit the sketch mode. You can call out the dimension by go to the annotation here and give a click here. Just enable the show bigger dimension. As you can see, all dimensions you add to your part just come out. It's very useful for display dimension. Another one is we're going to discuss about the name of the dimension later. Okay? You can go to view and show, you call out the dimension, right? So this dimension is D2. You can check the name of the dimension. This is D2 of the sketch tool. This is the D1 of sketch tool. This is the D3 of sketch tool. So that means you can track back to edit the dimension of the. Anyway, if you find it not easy to your eyes, disable it. Next, you finished this step already, right? Move to add the thickness, and the thickness is 10 millimeter. Sorry, I didn't bring the dimension out this slide. Add the thickness to this sketch. Click at the sketch number 2. Go to features and again to the extruded boss. This vector just showing the direction of the extrusion. So it's going to the different direction, right? If you play around, you might notice that there is one icon here. It's called reverse direction. If you click, your extrusion gonna go into the different direction. There is one option here, results. If you keep the result ticket, that means that this extrusion and the part here is merged into the same piece of material. Okay, and I would recommend you to keep this option ticked. You can OK, and this step is finished. We're gonna move on to the next step. What we're gonna do is to add the 3mm thick slots right here, and this 3mm thick is supposed to pass through the whole part. Let's go back to the work. Okay, you may, I think you, right now you can guess that we need to select it. It's not just a single answer. You can go to the different side and you can select this and start to work for the 3mm slots as well. It really depends on your choice. So in this case, I'm gonna work on this. Start to select this frame and go to sketch, right? Make angle. Then in this case, I want to use corner rectangle. It would be better than selecting the center and corner. For my conventional, for my convenience, there's the space bar and can normal to draw a rectangle. I start one corner over here and another corner maybe around here. As you can see, if I touch one point, there is some guideline to give me a location that I want. I want to have this vertical line aligned with this edge of the main part. So I just make, I just move my mouse to here, and it will be the guided dash line. Give me the guideline. Okay. Anyway, move here. And I can use this figure again. Make sure that this corner of my align with this one. Next, I'm gonna add the thickness. Yeah, this is 3mm. As you can see, we still move our sketch in this direction. Okay. What we need to do is we can constrain or add relation between this line and this edge. You can click the line first, and after that, you can press the control button on your keyboard and give a little click to the edge of the main part, and you can use co-link to make these two lines align it in the same line. This one repeat the process. Right? It's now the black already, and it is ready to go to the next step. Here we finish the sketch, and we're gonna add features. This time we're gonna use extruded cut. Click here, and I will suggest you to play around with this option. So in this case, we're gonna use throughout. Okay, when you click throughout, that means your main part gonna be cut through to the other side, like this. You can click here. Next, we finished this early. Next step, we're gonna add some holes to your parts. Many people just use circle and extruded cut to create holes. However, I don't recommend to do that because we have a feature, a little feature called hole width. We could use that one. So the whole wizard gonna link your three-dimensional model to the drawing, because when you draw, for example, shaded hole, you need to have a specific engineering drawing notation to create a drawing. But if you create hole by using circle, you don't have that kind of detail appear in your drawing. Okay, so in this case, we're gonna use the wizard. Go back here and to tool. You find the where we insert meter. Here we go. Always go to insert figures. Always. Right? So let's see how many holes do we have. We're gonna add a hole over here, right? This hole is going to be ANSI NSI metric expose the size M8 with normal, and we're gonna use the other bar. The hole will be placed at the center. So we go to the whole wizard feature, insert features and whole wizard. There will be the specific whole specification and dialog come out left side of the screen. You're going to use, actually there are many options. In this case, we're going to use Audible, and we're going to use the standard avenue selected and NSI metric, right? This is the type of screw of the type of bolt that's going to be fixed into this hole. In this case, we're going to select X bolt NSI B18 0.2, 0.3, 0.5 M. This is the default. And 8, right? With normal. And once you finish selecting the type of the hole, let's go to the position, this, and click add a 3D sketch button over here to add. You can use move your pencil icon to the edge of the semicircle, right? And you can identify the moving your mouse over. There will be a map to your mouse. Okay, you can have a click over here. Finish. That's it. Okay. Next, we're gonna add the curve to the corners. In this case, we're gonna use the feature called fillets. Okay. Just click at the fillets icon there. In this case, we have 1, 2, 3, 4, 5, 6 edges to be filleted. 1, 2, 3, 4, 5, 6. Okay. And we can select full preview just to check if selecting go into the good direction. Nice. Good. So you click OK. Yeah, that's done. And we need to add another fillet to all of the edges. Okay, but this time the radius of the fillet will be 3 millimeter. Previously, the radius of fillet is millimeter. So we call out another fillet figure. Okay, and then you specify the radius of the fillet. Millimeter. Click here. As you can see, line that are connected will be connected to the scene. You can right click and select all of the lines that is connected together to create loops. You can click to OK. I might get this one, right? So in this case, I can edit the fillet by even right click to fillet number 2 and select edit feature. Add more edge to this feature. Okay. Nice. All of the sharp corner are removed. Next, I need to add 2 more holes on the side here. But what we need to learn is you can control the feature manager here by move your mouse over this line, and if you left click, and you can roll back the feature. In this case, I roll back to fillet features. Just go back 2 steps. Okay. And at this step, we can add 2 holes. So I'm gonna again use the hole wizard in the figures width. Okay. And the position of the hole will be 10 millimeter from the horizontal side and 50 millimeter from the vertical side. So in this case, I would be useful to select the top view already. Go to positions because I still in the hole wizard. Anyway, we need to check first type of the hole that will be added. So it's like just a true hole, a simple hole. So go back to SolidWorks and specify the type of the hole. So what I want is this one, this hole, and that would be, I don't know, sorry, I haven't checked the dimension. So let's say it's 8 millimeter, like the previous one. So I select hole asymmetric, double hole. The circuit size. This really depends on the type of the hole. The size would be 8 millimeter. Scroll down and select 8. You can also use the screw clearance, right? And you can specify the size of your screw. In this case, I can select M8, and SolidWorks will then calculate, or I would say it's a lookup table to specify the size to fit to be fit with the M8 screw. So this is the whole asymmetric screw clearance M8. The position, select 3D sketch. Let's do hold one there and another one there. And I'm gonna press the escape button to get out from the position selection feature. And I'm gonna apply the dimension of the hole. In this case, it's going to be 10 millimeter and 15 millimeter. Millimeter, right? 15 millimeter. You can use this one. This is we can because we know that this two is symmetric. So I'm gonna draw a center line. You can generate you can create a center line by click at the dot list over here and select center line. Then we do it again. Okay. Here, line. After that, you can find the midpoint by move your mouse over this line. As you can see, this is midpoint. You can add a midpoint. So after that, you can say this one are symmetric. Okay. Symmetric. No, sorry, we cannot do this because this is a 3D. Just forget it. Anyway, let's finish this by simply add the start dimension. This is 50. If I click, that's it. Once you finish this, you can move the line to cover to flex features. Okay. If you click, hold your left button. Okay. Press the space bar and go to the isometric view. That's it. We have already finished this 3D part. Last but not least, you also can add some feature, right? Because last time I introduced you about the material already. Add ABS, transparent material. So can add the metal cast iron. This is and use the nickel. It depends on the type of material and carbon steel. And you can go to this section, which is the appearances, themes, and details. You click here, and you can change the appearance of the part. For example, if you want to make it look like brass, you just click this brass. Signal brass, or blush brass, satin finish brass. You would not see this effect until you go to the render preview. Okay, so for example, if I use a polish glass use the photo view 360 to make a render of this part. You're gonna see the shiny surface of your three-dimensional model. We will discuss about a rendering in more detail later. Maybe so big. Okay, sometimes you use rendering idea view. Rendering screen. Wow. Yeah, nice. Easy peasy. Okay, this is a look. And go back to SolidWorks. Yeah. Okay, and that should be everything for this video. I really hope that this video is useful for you. Yeah, try to practice. You'll be very fluent with the SolidWorks. Okay, give me a second. I forget to mention about this was you actually can move feature to a different level. For example, for this render screen first. For example, you can move M8 balance all to the one step before you create the color ball. Okay, it's just a swap of the step. But if you want to do this, you need to make sure that if you move some feature to the previous step, your feature would not abrupt the step in creating path. For example, you cannot move M8 branch to the first step, right? Because you cannot move this to this step, right? Because if you just create this bit, the year of your path at the second step. That means you cannot have a C-bore before you create this the year of your path. Okay? Apart from that, you can move to the different step. Okay? Yeah, and that should be everything from this video. And we hope that you enjoy watching this tutorial. And I'll come back to see you in next video. Thank you for watching. Bye bye.